Hi, it's Bruce again, and welcome once again to my Colorado Rocky Mountain lab. Today, what I'm taking a look at is an EIP model 548A microwave frequency counter. This is a 12-digit counter that can measure frequencies from about 10 hertz up to about 26.5 gigahertz in this case. It does so remarkably accurately, and along the way has some mathematical functions that make it interesting as well. The unit is operated. We have three ports, input ports. If we want to read between 10 hertz and 100 megahertz, we can use port 1 here. They labeled it band 1. If we want to go between 10 megahertz and a gigahertz, we use band 2, and if we want to measure 1 gigahertz up to a whopping 26.5 gigahertz, band 3. You physically move your connector, and right now I'm still trying to read off of band 2, so I've got to tell it to redirect itself. So I'll say change to band 1, and we see that we just switched our readings to band 1 now. We have an adjustable sample rate on this thing. If I am trying to read anything down to a hertz, then I've got to be able to give myself 1 second plus 1/10 of a second for the reading to reset and everything. So about once every second, and I can read right down to the hertz. It's in very nice condition, very attractive case. There's a little wear on the paper decals that were placed on the top that give you some directions for use. The right hand one here pretty much doesn't apply because this is for options that we don't have. The left one is for the frequency measurements, which does apply directly. There's a little wear on the paper on this, but that's really where the wear is. There is no other wear apparent on the unit. It's in quite beautiful shape. Yeah, take a look at the back. Has an input on the back for an external time base input. I'm using my bench time base at the moment. By doing that, that helps calibrate my my bench, or calibrate the unit to my bench. Everything will work in concert, which is really a nice thing to have. Although the internal time base on this thing is quite accurate too, and I'll demonstrate that in a bit. Okay, so we're on band 2 right now, and if you can see the indications here, it says band 2. We're using our external reference, so we're not using the internal time base, but that just means that we are calibrated to our bench at the moment. We are reading 100 megahertz from this little unit right here, and we have 100 megahertz showing on the screen. So let's go ahead and take her up to 200 megahertz, 300, 400, 500, 600, 700, 800, 900, a gig. Okay, and that's all on band 2. If we take it from band 2, put her into band 3, band 3 is capable of reading up to 26.5 gigahertz. Unfortunately, most I can produce here on the bench is 9, but we'll provide it. Now we're showing a gigahertz on band 3. Let's go 2 gigahertz, 3 gigahertz, 4 gigahertz, 5, 6, 7, 8, 9. Okay, I just plugged my my bench master oscillator back in after calibration. Calibrated it against my rubidium standard, and right now we're looking at the standard versus the output of the bench oscillator at 10 megahertz. And as you can see, the Lissajous pattern is it's slowing down. It's getting even slower than it was as it's heating up, but essentially standing still. So the relationship between the bench oscillator and the rubidium is that the frequencies are equal, at least to a very, very close degree, which is what I want, because I'm going to turn off my my rubidium, which right now is in lock. You can see the green lights on lock. Well, that, by the way, is the bench oscillator up above. Okay, I'm going to go ahead and kill the power on the rubidium and save its life. Ooh, pardon me for that. I had to reach back there. Okay. Rubidium's off, and we will proceed. Okay, so this is what I was after. Now that I know that my bench oscillator is adjusted as closely as I can get it to 10 megahertz at this particular temperature in the room right now. Anyway, we're looking at the TCXO that's inside of this EIP microwave unit, and we can see that we got a hertz or two of difference. So I suppose I'm going to open this thing up and adjust it, but I'm going to do so when the temperature is stabilized. So hang in there. Okay, so here's the inside of the EIP microwave frequency meter, and we have the TCXO is right here. So there's an adjustment spot right there, and I'm feeding in the TCXO output on one point, and I'm looking at the bench oscillator on the other, and then I'm adjusting this thing to try and get that Lissajous pattern to stop. Alright, and I'm turning it up just a little bit here. There we go. Alright, we're getting right there. I'd say we're just about there, so I'm going to hold it. We'll stick the cover back on and just let it heat up a little bit, see what happens. Okay, well, it's been several minutes since I made the adjustment. You can see the Lissajous is standing still. The temperature in the room is about 73 degrees, which I can tell you for up here in the mountains in early springtime, that's pretty warm. I usually have about 68, maybe 66 in here, but I kicked it up because I figured it'd be more representative of temperatures elsewhere. And we can see right now the bench, it's reading the bench oscillator at about 10 megahertz, so that's good. That's what we want. And I'm going to go ahead and button her up. Okay, so we have the EIP 548A right now registering 8 gigahertz on the band 3 input, which is 1 gigahertz to 26.5 gigahertz. We're outputting from that little wideband signal generator up there. And we're going to go ahead and step her down. Alright, let's take her down to 7, 6, 5, 4, 3, 2, 1. So at a gigahertz, we're showing what? 999,999,916 hertz. So we're actually 17 hertz. So we're about 83, 82 hertz now off of a 1,000 megahertz. Pretty wild, huh? Okay, so what we're going to do, we're going to go ahead and disconnect, and we're going to move to band 2, and we'll take a look at it. So on band 2 right now, again, I'm reading 999,999,930 hertz at this point. Okay, so we're in band 2 right now. We're pumping in a 500 megahertz signal, and that's coming from this PTS 500. We're reading 499,999,990. So we're 10 hertz off at 500 megahertz at the moment. And we're climbing 992, so we're 8 hertz. So let's go ahead and take her to, this is 500, let's go to 400. Alright, there's 400, 300. 200. It would be 100. 90. 80. 70. 60. 50, 40, 30, 20, 10. Here's actually, we at 10 are theoretically at the end of our band 2, so we really should go to band 1 and pick up again. So let's do that. Okay, we're at 10 megahertz right now. We actually can go to 100 megahertz on the max end of band 1. So here's 110 megahertz. I'll take the 100 out and we'll start at the 10, 9, 8, 7, 6, 5. We're running about a hertz difference here. 4, 3, 2, 1. And at this point I really should actually switch generators again and go to something that is capable of audio range in order to continue. So bear with me, we'll do that. Okay, so we've got this DDS signal generator putting in our audio signals at this point, or audio range. We can take her up. Here's 900, there's a megacycle, so there's 900, 800, 7, 6, 5, 4, 3, 2, 1. 90, 80, 70, 60, 50, 40, 30, 20, 10. There's 9, 8, 7, 6, 5, 4, 3, 2, I went to 1, 900, 800, 700, 600, 500, 400, 300, 200, 100. All right, there's 90 hertz, 80, 70, 60, 50, 40, 30, 20. There's 10. 10 hertz is supposedly the lowest frequency readable on band 1. Okay, so we've got a 9 gig signal on there right now. And what I want to do is just try and use some of these functions that they have available on the keypad. So let's start with resolution. So the way that works, it says resolution right above the number 2 button here. So the first thing you do is you hit that button for resolution, and then you give it a 0, 1, 2, 3, 4, 5, 6, where that represents the decimal place that you want to keep the resolution to. So let's say we want to go to kilohertz. That'd be a 3. Okay, so I've wiped out the first 3 leading zeros, and we're displaying from kilohertz up to the 9 gig. And what happens is the gate speeds up and you update a little more frequently. Let's try it again. Let's this time go to 6. All right, so there's 9,000 megahertz. And we can watch the gate just very quickly blip. It takes no time at all. Okay. Well, let's take the resolution back all the way to full 12 digits. All right, so resolution worked. Okay, so we're going to do a gigahertz, and we'll see if we can multiply that. So we've got a gigahertz on the unit. Okay, and what we want to do is we hit multiply up here. Then it wants me to put in a number. Let's right now it's got the number 1 in there, but let's multiply it by 0.3. Okay, we got 3 gig on there. Let's multiply 0.4. There's 4 gig. So the multiplying is working. but you can't do fractional multiplication. That's too bad. We can do frequency offsets. So let's do a frequency offset, and it wants me to put something in, and what I'm going to do is I'm going to subtract 500 megahertz off of that. 500 megahertz. Okay, so we had 4 megahertz, now we've got 3.5. Why is that? Because we took the original gigahertz, we multiplied it by 4, it got 4 gigahertz, and then we subtracted 500 megahertz and we get 3.5 gigahertz. So that worked. Let's cancel all of that. Let's see, we'll go multiplication, data clear, and then we'll go offset frequency, data clear. We're back to the original gigahertz. So okay, we've run through the whole thing. We've given you the tour, shown you how it works, calibrated it, showed you how we did that. You give this thing a little warm-up period, and it'll work quite well. Keep your temperature at around 73 if you can. As we said, it's in beautiful shape. It's going to be a beautiful counter for somebody's bench. So thank you for listening, and we'll see you again.